Hi friends, welcome to my lecture series on random variables and stochastic process. In this video, we are going to discuss about the random variables and classification of the random variables and the conditions for a function to be a random variable. The first one we go for what actually we mean by random variable. So random variable is a function that map all the sample space to a point on a real axis. Let's consider we are performing an experiment such as tossing two fair coins and the corresponding sample space is tail tail, tail head, head tail and the head head. The random variable I am considering as x, it is going to be used to count number of heads. So here let consider this the your corresponding the function of a random variable x, and each sample element of the sample space is passed through this particular function, then they are going to be mapped to a real axis such that, so whenever this tail is passing through the random variable x, it is count for the number of heads, and as the tail is passed, then this is going to be assigned to a value as the 0, and whenever the tail and head is passed, then it is going to be mapped to a value as the 1. As the tail head is get passed, then it is going to be mapped to the value 1. Head is passed to the function, then it is mapped to the value 2. So it means the sample space is get mapped to the real axis, then our corresponding random variable capital X is going to be having the values at the 0, 1, 1 and the 2. This is the corresponding random variable. So simply say that this random variable is a function that map the sample space to the real values, right? And then go for another example over here. Let's consider in a class there are 5 students such as S1, S2, S3, S4 and S5, and we are going to map these students to a real number. So where we are considering a random variable, let's consider the y, and the definition of this particular function is going to be defined such that it is going to be calculate the age of the student. Then whenever we are considering the student 1, then it is going to be assigned a one particular value in the real axis. We know the real axis is going to be having the range of minus infinity to the plus infinity. Then the student age is going to be something like as in 19 years. Let's consider student 2, he is also having the age of 19 years, and the student 3 having the age of, let's consider 21 years, student 4 having the age of, consider 20 years, and student 5 is having the age of 18 years. So this is the corresponding mapping, nothing but the sample space is going to get mapped to the real axis over here. Based on this, we come to represent the conditions for the conditions here. The first condition is the sample element is going to be assigned to the one point on real axis. Here the 1 point nothing but only 1 point. For example, we can't say that the student 1 is having the 19 years as well as the student 1 is having the 21 years. So this is not get carried. It means one particular sample element is going to be assigned to only one real number. Second one, 2 or more sample elements may assign to one real number. Similarly, if you observe here, student 1 is having the 19 years. Similarly, student 2 is also having the 19 years. Nothing but 2 sample element may assign to the one real number, but one sample element can't be assigned to the two numbers over here. Come to the third point. We know the sampling element are having the probability. In the similar fashion, there we are going to be having the probability of the random variables, and the probability of the random variable is going to represent as the probability of x is equal to small x. So these are the corresponding conditions for a function to be a random variable. Conditions for function to be a random variable. So then we come to the classification of the random variables. Random variables are classified into the three main categories as a discrete random variable, continuous random variable, and the mixed random variable. The discrete random variable, nothing but the random variable is going to be having the elements in the discrete formation such as a comma b comma c and so on, or else the 1 2 3 4 something like this. This type of representation is to be named as the discrete random variables. Continuous random variables. In the continuous random variable, the corresponding random variable is going to be having the range of elements. For example, a less than x less than or equal to b. It means it is going to be having all the values in the range of a to the b. Similarly, x is equal to 1 less than or equal to x less than or equal to 3. So here it is going to be having all the values in the range of 1 to the 3, such as 1, 1.0001, something like this. In this fashion, all the elements are going to be get carried over here in this particular range. Come to the mixed random variables. Mixed random variables are nothing but the combination of both discrete as well as the continuous random variables, such as random variable x is equal to 1, 2, 3 less than x less than or equal to 4. On observing here, the corresponding random variable is having the discrete mode from the 1 to 3, and from the 3 to the 4 it is going to be having the continuous mode of representation. These are the corresponding classification of the random variables. With this we are going to be stop our session over here, and we are going to be discuss the corresponding probability distribution and density functions in the upcoming classes. Thank you.